All right, you guys, let's tackle example 2. If you felt like example 1 was a breeze, I highly recommend that you don't listen to me because I know my voice can be annoying after a while. I'm sorry about that. Okay, but you don't have to listen to me, and you can try it on your own, but otherwise, let's get going. Okay, so Mark is a wrestler that weighs 175 pounds. Holy hot dog. Okay, in order to compete in his weight class, he can weigh no more than 3 pounds off of his weight before he competes. Guys, so if you didn't know, which I don't know if this is actually the correct way that weight classes work in wrestling, but in wrestling, you have to make a certain weight in order to wrestle in certain weight classes. So you actually wrestle people that kind of weigh similar to you, so it's fair. So usually when people are wrestling, they weigh in before they wrestle, and that determines if they can actually compete in the match or not. Because if you're not in your weight class, then you can't compete. It's kind of sad. But anyway, so Mark is a wrestler that weighs 175 pounds. In order to compete in his weight class, he can weigh no more than 3 pounds off his weight before he competes. What is the acceptable weight range that Mark can be to compete in his weight class? Write an absolute value inequality to represent the situation and solve/graph the inequality. All right, so let's find this range that Mark could be, okay? So let's find the lowest weight he could be to be in this weight class and the highest weight he could be. Okay, so we know, I see that Mark is 175, so I'm going to underline that because that looks important. Okay? So I know that he can be up to 3 pounds off of his weight. So what does that mean we do with the 3? We do have to add it one time and subtract it one time. The first time I'm going to add the 3. The second time I'm going to subtract the 3. Oh. All right, which 175 plus 3 is 178. And 175 minus 3 is 172. All right, so Mark can be the range he can be between to wrestle, because he really wants to wrestle, so I hope he's in this range. He can be anywhere from 172 to 178. Okay, which if we set up our inequality, okay, the numbers in here are all larger than 172 and all smaller than 178. So we are greater than 172 and less than 178. Okay, and we put the equal to sign because it can equal those values. Okay, and now we need to set up our inequality, which don't forget, it always kind of looks like this. So x minus a number in absolute value is less than, greater than, less than or equal to, greater than or equal to the number where the sign changes. Okay, this one is where it does not change. Okay, so let's set this up. So we have x minus a number. Okay, so what is the number that does not change? Because remember, that's what goes right here. So when we were adding and subtracting here, the number that never changed was the 175. It stayed the same both times. So this is minus 175. And it says he can weigh no more than 3. So what kind of inequality symbol do you guys think that we're going to be using? If he can't be any more than 3 pounds, like could he be 6 pounds above or below? Absolutely not. I agree. You got to shake your finger like that. Absolutely not. All right, so he cannot be 6 pounds above. So we can't be larger than 3. Is it acceptable if Mark is 1 pound above or below? If he was 1 pound above, he'd be 176. If he was 1 pound below, he'd be 174. Is that in the range? Yes, it is. So we can be smaller than 3, but not greater than 3. So I know it's a less than. I know it's a less than. And he can be up to 3. It says no more than 3. But 3 is acceptable, so it's going to be equal to. And then remember, the thing that goes here is the part that changes signs. So what part changes signs but stays the same? It is the 3. So I'm going to put my 3 right here. All right, and then from here we just solve like we normally do. So I'm going to split my paper in half to make it organized because I like to be organized. Okay, remember on one side we write it just like it is. The other side we flip the symbol and flip the sign on the 3. But this part stays the same. So I'm going to write this part twice so I don't try to change anything and mess it up. So this part gets written twice. On one side, we keep the symbol and the sign, so less than or equal to 3. On the other side, we flip the symbol. Oh, my hand hurts like that. Flip the symbol and the sign, so greater than or equal to -3. All right, let's see if I can solve in this problem and not mess up like I did in the last one because the demon cats got me really bad. All right, so how do you bring -175 to the other side? You do add it on both sides. You guys are freakishly smart. So -175 plus 175 cancels and turns to 0. And 3 plus 175 is 178. So x is less than or equal to 178, which we already have part of the inequality right here. X is less than or equal to 178, which, sorry, I don't know if I was blocking that or not. Sorry if I was. All right, same here. To bring -175 over, we add that bad boy. Bam and bam. Which -175 plus 175 cancels. Bam, and turns to 0. So we get x is greater than or equal to -3 plus 175, which is 1 to the 7 to the 2. 172. And guess what, you guys? We have the other half of the inequality. X is greater than or equal to 172. X is greater than or equal to 172. Yes. All right, the last step is to set up this graph right here, our number line. Okay, so we put the smaller number here and the larger number here. Which one of these is the smaller number? Nice, you guys. 172 and 178 will go over here. Okay? All right, so on this first one, let's start with 172. I'm going to use purple for that one. So it says x is greater than or equal to 172. Which way do I go if I am greater than 172? To the left or right? Insane, you guys. You go to the right. Nice. And also remember, it's like the arrows pointing that way. Okay? All right, and this one, x is less than or equal to 178, which means it's going to be this way because these numbers are smaller than 178. Also, the inequality is kind of pointing that way, so we're going to go that way. And I shaded these in because remember, if it's equal to, we shade in. Okay, so let's see here. Did the cars crash and die and burn? It's kind of sad. Or did they go opposite ways and never touch? They do crash and burn, and there's blood and guts, and it's gross. Okay, so we do shade between, and we should know that because we already know our answer is an and. So yes, this is our answer as an inequality. And then our graph will look like this. So these will be shaded in because both of these are equal to. And then we shade in between. Yay! And guess what, you guys? That's it with that one. The Funsy's going to be great, so get excited for that. Nice job.